Welcome back to Learning Solidity. Now in today's tutorial we are finally going to be covering tokens. This tutorial is actually going to be broken up into three parts, and the three parts will be the ERC20 standards of developing Ethereum tokens, the ERC223 standard of developing Ethereum tokens, and finally the ability to publish tokens to the Ethereum network. And I will actually show you using the Romston test network how this is done. So sticking with today's tutorial, I've already opened the page to the Ethereum token sort of homepage. Now there is this concept of minimal viable token, as you can see in front of us now, where we simply have a constructor and a transfer ability. This doesn't really work in practice if you actually want to utilize your token to its full extent. So to actually make sure that we actually do have our token sort of developed to our full extent, we're going to look at the ERC20 standards. Now I will leave a link to this page in the description box below if you do want to have a look at it, but let's jump into Remix. Now I've already predefined a couple of files in Remix, and these two files are ERC20, which is simply an interface, and this is just creating a simple set of constraints for us. Now what we have here is, I'm going to break it down function by function. To begin with, we have total supply. Now total supply is simply returning the amount of tokens we actually have in circulation. Then we have balance of. Now this is finding out the balance of how many tokens a specific address has. Pardon me. We have then the function of transfer, and this is a function which allows a specific user to transfer their own tokens to someone else. We then have transfer from, where anyone can specify a user to transfer tokens from, which then can transfer tokens to someone else themselves. But there is some constraints with this, which is basically going to be covered in the next two functions. Now the next function is approve, and what this is basically you as a token owner is saying that someone can basically manipulate tokens on your behalf. This is where the transfer from comes from. So for instance, if you have 100 tokens, you can say I want to allow spender this address 10 of my tokens, and he can do with them as he wills. So obviously the other address can then decide he wants to send 10 or 5 of your tokens to another address. So it's a way of being able to manage a balance of a specific address from essentially a third-party address. And finally, the allowance function. Now the allowance function is just simply a way of displaying how much a specific Ethereum address can manipulate another Ethereum address. I'm probably not describing this very well, but as I sort of develop the code, obviously it should become a little bit more clearer. And the final two things are in the interface is basically just two events. Now I have noticed something about this kind of straight off the bat. I'm not sure if events will work from an interface. I'm going to let it ride for now, but this is something I might have to readdress as I come now. And this is basically just some sort of logging, or basically additional logging to the ledger that certain events have happened, say transfers happened and an approval has happened. So with this in mind, let's kind of start developing our token. Now I've created a contract called my token. I've obviously imported the ERC20 interface, and I've also applied it to our token. So the first thing that we're going to have a problem with here if we try and compile it or try and create it is it's not going to allow us to create because we haven't created all our constraints. So let's start with the basics. So if we jump back, the first thing we've got to deal with is the total supply. Okay, so let's jump back into my token even, sorry. So we need to create a function, and this is going to be called total supply. It's simply a constant because the value shouldn't change, and what we want to return, or we're returning, is another uint of underscore total supply. Now all we need to do now is return the amount of initial tokens that we're actually going to create. So for this, what I'm going to do is I'm going to define a uint. I'm going to make it private. I'm going to also say it's constant, and I'm also going to say it's underscore total supply. And also at this point as well, because it's a constant, I also have to initialize and set the value. So I'm just going to say for my my first token, I'm only going to allow 1,000 tokens to be created. And all we simply have to do with that, because we're trying to stay within the boundaries of the constraints of the ERC20 interface, I do have to specify total supply is equal to _ total supply. And that's our first function. Now, it's probably worth noting at this point, I probably should have highlighted the 3 constants I've already defined within this constructor. Oh, sorry, within this contract, sorry. Now, the first one is symbol. Now, this is basically a shorthand way. I know, obviously, you probably know Bitcoin and Ethereum. They have essentially a symbol or a sort of an abbreviation. With Bitcoin, it's BTC, and Ethereum, it's ETH. So that's what we're essentially doing with our token here. So our symbol here is MFT, which is just an abbreviation for my first token. Obviously, the name is my first token because that's what it is, and we're specifying how many decimal places our token has. Pardon me. Now, for instance, obviously a Bitcoin, you don't handle just one Bitcoin, you handle a Bitcoin plus its decimal value as well. So in this case, we're also specifying how many decimal places basically our cryptocurrency has, or our token has. So like I say, that is pretty much it for those sort of definitions, and those are something that's identified if we actually have the certain amount of sort of requirements met in the creation or sort of outline of our token. So the next thing that we're going to be looking at now is balance of. So it's a balance of an address. So what we're going to need is somewhere to store our balances. So let's create a mapping, shall we? So mapping, again, we want this to be private because we don't want any outside interference, and we simply want to be able to, if I've done that right, I think it actually has to be mapping and then address and then a uint. Private, and that is going to be I'm going to stick with this double underscore just for consistency. Balance of. Okay, so now we need to create a corresponding function for this. So function balance of, then it's going to be an address. I'm going to simply call it ADDR, and we return a uint. I think there was a bit more to it than that. Let me just double check. Yes, we actually just return on balance. Just make sure I have definitely got that right. Balance of address, that's also a constant of as well. So let's return a constant. And now this is just simply return underscore balance of ADDR, and that is simply it. So that is all it is doing at the moment, is returning a balance of a specific address, and also returning the total supply of tokens within circulation. Okay, so the next thing we've got now is transfer. So we got transfer, our address to transfer to, a value, and we're going to return if it's successful or not. So let's create another function called transfer, and it's going to be address of 2. Actually, I just want to be a little bit more consistent here. Have an underscore there and one there. Address 2, comma, uint value. That returns a boolean, and I can't remember what the actual thing was called. Success. And there we have it. Now, we do actually need some checks in for this. Okay, so the first check that we've got to make sure is, do we have enough enough tokens to actually fulfill this actual transfer? So the first thing we're going to have to do is check that. So if underscore value is less than or equal to we can just use the actual balance of function now, balance of, and we also need to specify message sender because it's our own balance. Then what we can do now is of our own balance, so this would be underscore balance of, and that is message.sender. Now minus equals underscore value, and now we need to do a basically the polar opposite for these who we send it to. So balance of _2. Let's add the same value back to them. We also want to return true, and obviously if we don't match that, we simply want to return false. And that should be a very sort of simple way to actually ensure that works. There's probably a few more constraints that we could potentially do to ensure that this is correct as well. For instance, like we also want to make sure that in this case underscore value is more than 0, because we don't want them to be able to transfer 0, because that really does nothing, just unnecessarily just adds extra load to the network. And I think that should just about cover it. Yep, that should be fine. Now there's probably some more logic I could potentially add to that. Now I do have a little template to my side here just to kind of recap me so I don't actually make any massive mistakes. But that should be a very basic way of doing it. Now I just want to kind of make this clear that this is probably going to be far from perfect, because I'm doing this as I go, and if I was going to sit down and do this, I probably would take a slightly different approach, add a lot more error checking as I go. I'm just doing this in a very loose manner just to give everyone an understanding of how the actual ERC20 standard is applied, but I'm going to move on from that now. So we've got a transfer. Now I would do the transfer from, but I actually want to, I'm going to do the approve first. So actually, to save a bit of time, I'm going to copy this because it saves me actually having to get it wrong. And in fact, I'm going to save myself a lot of time here and copy the last set of remaining functions and just paste them in. That didn't paste all of them. Missed allowance. Okay. So what we have here is our transfer from, which we're going to leave for now because I want to address the others. And for some reason I can't scroll to the end of that. There we go. So I'm going to have to move the webcam. Sorry, I've actually put this blocking my own screen. So let's have a look. Right, okay, sorry about that. Right, so we have the three methods remaining. So transfer from, approve, and allowance. Now the first thing that we actually need to do is be able to sort of approve someone has access to a certain amount of value. Okay, so we're going to need again another mapping structure. So in this case, because we're mapping an address to essentially another address, so we're going to need a mapping again, so a mapping of a mapping, which again is going to be an address to a uint, and that's going to be private, and this is going to be, I'm just going to call it allowances. Okay, again it's a little bit convoluted this, but it should come to light very shortly. So our approval is going to be our allowances, so message.sender, because that's us. We're going to allow the spender to have a value of essentially just value. I'm going to also put a check in as well. Ooh, this could actually come up with a few problems. If we're allowing that person to be able to transfer, actually for now, because they have that allowance, I'm not going to add any more constraints to that, because I'm going to add the checks to the transfer from. So that should, well, pretty much just return true, because there should be no issues with doing that. You could add a bit more constraint there if you wanted to, but for now I'm just going to leave it with that. What I am going to do here for the allowance, because the allowance is now showing how much that specific person has to an address, let's just do, so return, actually first I'm going to do the check, because we could get an undefined here. So if we get this right, allowances owner message.sender So first we're checking to see if that exists, because if we try and access that, that potentially might not be a map. I think it is, but I'm just going to make sure anyway. We are then going to return. Actually, I'm going to do it on that level to check if that exists first, and then return that, otherwise return 0. Trying to think, did that work previously? I don't think I actually tested that previously, but I'm going to leave it with that for now, because that could cause an issue if the owner is undefined. Okay, let's move on from that to our transfer from. Okay, now in the transfer from, this is basically where we're allowing someone else to transfer from our wallet on kind of our behalf. So let's simply state we've got a couple of rules we're going to have to add first. So let's do a bit of an big if statement here. If the first things first, allowances underscore from, let's make sure that exists, and the allowances underscore from underscore to, actually no, sorry, this is incorrect, it's message.sender is greater than 0, and the value is greater than 0, and the message sender is also greater than or equal to the value. Okay, now that should have covered all bases for those checks. Again, I might have missed something, but I think I should be alright with that one. Now, if obviously those don't pass, we're going to return false. And if they are true, again, we have to do the same logic as we did before. So balance of from is going to be minus equal the value. The balance of to is going to be plus equal the value, and then we're simply going to return true. Okay, we have a few issues. Let's have a check to see what these are. And not compliant. Bool. I think it's because that is always going to return. So let's just remove that. Probably should have picked on that before I started checking those. So I think if I'm correct, that should always return, which would resolve all those issues. So let's actually just give that a quick check, shall we? What do we have here? Warning, unused local variable. Where have I unused something? Allowance of owner. That should be spender, because it's simply a check. Okay, hopefully I haven't missed too much with all this. Let's bring up our contract tool. Okay, so we create the contract. Let's do some very, very simple things. Okay. Let's transfer. It's not that easy to actually test this thinking it through, because when we specify an address, it is going to be a little bit tricky to test. I think I'm going to leave the testing of this till the third part of this tutorial, because for now I just pretty much wanted to focus on the code. The only issue is basically just creating an address. I usually actually had a function that would convert a string to an address and then send it from there. I can't remember off the top of my head the exact structure for JSON for sending an address. But like I said, I'll kind of cover that in a later tutorial. But for now, I'm going to kind of like leave off here, because this is covering the very basics of an ERC20 standard token. So we have a list of balances, we have a list of allowances, we also have a total supply of our currency. Now, a few additional things that we probably should have had here. We have total supply, but we don't actually have anything to indicate the amount of tokens in circulation. So obviously, when attributing tokens, we always wanted to make sure that the tokens have been attributed correctly. So potentially something else that we could have done there was simply state the function my first token, and then simply specified that balance of message.sender is equal to the total supply. Now this is basically saying that me because I've created this contract, I have all of the tokens available for this token essentially. And that basically means that there should be sort of no manipulation, because all the rest of our sort of transfer functionality only transfers from one address to another. It doesn't actually have the ability to add and sort of create tokens out of thin air. So if I've got the full supply of tokens, no one else can just randomly have a magical value of these tokens. So like I say, in a nutshell, that is pretty much the ERC20 standard token. Now if I were to actually publish this on the Ethereum blockchain, it would automatically detect this as a token due to the fact that it matches the basic constraints here of having a balance of and transfer. So it doesn't matter whether, I know when it comes down to Ethereum, the balance of and transfer can actually either be, transfer has to be a function, but balance of can be a variable. So you could set it up like that, but that's actually something we're going to look at when we cover the ERC223 token definitions. Either way, I hope this wasn't too convoluted and I explained it well. I don't feel like I probably explained it as best as I could have, and I'll try and be a bit more descriptive when I'm covering the ERC223 standards. But like I say, in a nutshell, this is simply a way of defining the total supply of tokens in the contract, a balance of an address, transfer from a specific user to another based off the sender, transfer from one address to another address based off if that user has approval to do so. Obviously then we have the functionality to approve a user can send a specific value, and then simply a function that dictates or tells us how much one specific user can transfer from another user's token balance. And I think I'm going to call it there for now. Now I hope you did actually find this somewhat useful. There is a lot more to this than basically meets the eye. I wouldn't ever just copy and paste this and say, okay, that's going to be my token, because I've probably missed something. I can almost guarantee I've missed something somewhere, or something I've forgot to check. But yeah, there we go. There's a simple ERC20 token. If you did actually find this useful, please give it a thumbs up, and if you want to stay in sort of the loop of when I produce my next video, hit the subscribe button and you'll be notified every time I produce a video. And if you have any questions or feedback, feel free to leave a comment down below. But until next time, I will see you around.